Good day, Dr. Bridge and Mr. Singh. My name is Olsha Benjamin, and today I have with me my colleagues Turl Jack, Jonathan Wong, Makila Luke, and Ryan Cummings. And we are here today to present to you our proposal for the design of a circuit board recycling machine. Before we start our presentation, each member will briefly tell you what they as an individual bring to our team. Now we will begin with Ryan.
The skills and attributes that I bring to the design team include a strong understanding of the industrial process, a understanding of green design and manufacturing, and most importantly, to define and assess real-world problems, and my prior work experiences in the green industry.
The attribute that I bring to the table is that when I'm presented with a time constraint, I'm able to work well under pressure, and I believe that this will be very beneficial to us as a group because I will be able to keep the group calm and collected at all times.
My engineering attributes to this team are design skills and interpersonal skills. I've also developed over time leadership skills while still remaining a team player, which drives me to always want to make a change one way or another.
Hi, the skills that I attain are that I work efficiently and effectively when performing a task. I work well with others, and I have some experience in the mechanical field which will help in the designing aspect of this level.
Because of my love for maths, I have a passion for numbers, an eye for detail, and great critical thinking skills, which will be necessary for the overall success of this project. Now we come to the end of our introductory video, and we will now begin our presentation. Thank you.
Hi, my name is Olsha Benjamin, and I will start our presentation for today. Let's begin. What is a circuit board? A circuit board is a self-sufficient module comprising of interrelated electronic components. Circuit boards can be found in devices such as cell phones, laptops, and television devices. When did the first circuit board come into usage? The first patent, which was called the printed wire, was issued in the early 1900s by a United States native called Charles Dukas. And what this patent said was that PCBs will have an electrical pathway directly on its surface that was insulated via printing through a stencil with electrically conductive ink. However, just after World War II, PCBs were recognized. The first operational printed wiring board was created in 1943 and was used as a replacement for bulky radio tube wiring. The first operational printed wiring led to the creation of radios, telephones, and also amplifiers. The evolution of printed circuit boards, the past, the now, the future. Past PCBs were bulky, made from materials such as bakelite, masonite, thin pieces of wood, rods, and metal strips. They were also only printed on one side, and their components were connected using through-hole technology. This is a picture of our old circuit board. PCBs now use surface-mounted technologies and are made from materials such as gold, palladium, silver, copper, fiberglass, and other materials. Circuit boards now are also single-sided, double-sided, and multi-layered. They are also small and compact. What is expected of future circuit boards? They should use package-on-package method, three-dimensional molded plastic boards. Also, there should be an increase of integrated circuit chip use, as well as the embedded components will keep the design and manufacture of printed circuit boards a constantly evolving industry in the years to come.
Types of circuit boards. There are three types of circuit boards, such as 1. Single-sided, double-sided, and multi-layered printed circuit boards. Single-sided PCBs includes just one layer of base material, also known as substrate. Only one side of the board would have electrical components, while on the other side, the solder is solidified to the component's lead to keep it in place. Sadly, they're rarely used because of their intrinsic design limitations. On the other hand, double-sided PCBs use both sides of the board's substrates, including metal conductive layers, which elements are attached to. Holes in the PCB let circuits on a single side to attach to circuits on the other side using one of two techniques: through-hole and surface mount technology, as pointed out before. Now, for multi-layered PCBs, extra layers are added beyond the top and bottom layers seen in a configuration of the double-sided shown before. This allows the multi-layered PCB to be comprised of more components than other boards discussed previously. An integrated circuit, sometimes called a microchip, introduced in the year 1958, is a semiconductor wafer on which thousands of tiny resistors, capacitors, and transistors are fabricated. These types of chips can function as an amplifier, timer, or microprocessor, and much more. Thanks to these microchips, more components are able to fit on a printed circuit board, thereby making it more compact and useful in today's world. Sadly, there are several reasons why circuit boards fail. These are due to environmental factors, burnt components, acid traps, and other design flaws. But it's important to recycle circuit boards. Why? Because 1. It reduces the amount of electronic scrap heading to the landfills. 2. It produces revenue for work. And 3. The working components can be reused. The problem statement states, the disposal of printed circuited boards have always been a prominent problem in the electronic industry, since the primary disposal methods are a threat to the environment. In this regard, there is an increasing need for more environmentally friendly methods such as recycling. Industrial Solutions Ltd. has contracted our engineering firm to design a machine that is capable of deconstructing printed circuit boards, that is, PC motherboards, for recycling purposes. Our aim as a team is to design a machine that is capable of deconstructing used single-sided printed circuit boards so that its electrical components can be reused. In order to do this, we as a team need to first accomplish certain objectives, such as to conduct a comprehensive literature and patent review, to understand the fundamental process of circuit board decomposition, to develop required specifications for the design, to develop alternative designs for circuit board decomposition, and select a design that best accomplishes the desired task of requirement, to test and analyze the chosen design, and also to obtain engineering and manufacturing certifications for chosen design.
Hello, my name is Makila Luke, and for this section of the project, I will be doing a general overview on the patents. Up first, we have the parts disassembly apparatus, and this patent deals with the removal of components from a printed circuit board via the disassembly of parts method, as the title implies. The PCB, which is short for printed circuit board, is heated in a furnace via an IR heater at about 190 to 250 degrees Celsius in order to melt the solder. After the solder is melted, an external force is applied in order to dislodge the components from the circuit board, and this is done with the help of metal brushes to scrape the components off. Moving on to patent number 2, we have the process for depopulating a circuit board. Purpose of this invention is to remove electrical components from a PCB in a suitable manner so that it can be reused. What happens here is that the PCB is transported via a conveyor belt to a heating section which uses electromagnetic radiation to heat boards. Solder is melted and a mechanical force is used to nudge the components off the circuit board. After this is done, the components are then subjected to a gravitational force and it is sent to the first collecting location. Lastly, we have the last patent, which is the process and apparatus for the automatic removal of the components. This focuses on the automatic removal of components mounted on a PCB as the name implies. The device consists of a lighting device, an optical sensor, an image processing system, and a device to remove components. The PCB is heated in order to allow the differentiation between the components and the printed circuit board, and this is done due to their varying thermal conductivities. After the heat is applied and the solder is melted, a gripper is used to take the components off the circuit board. And after the automatic removal of the components that are recyclable, they are sorted and then they are stored in various slots for further use. Now, we will look at the removal of solder, and this is done using various techniques. However, for this project, we will be looking at two. The first one being a desoldering braid or wick. Solder is removed from a joint using a wicking technique via a solder braid. And what happens is that the braid is placed on a solid solder. It is then pressed gently with the tip of a heated soldering iron, and the solder is then melted, and it is then rapidly absorbed by the braid or wick. The disadvantage of this method, however, is that it is efficient, but it is proven to be slow as each soldering joint has to be worked individually. So the second method that we will look at is the desoldering with a heating gun, and this is one of the most common methods that are used. What happens in this method is that the board is strategically placed on a very flat surface, and then the heating gun is used to desolder the components within a matter of seconds. The solder is melted while the components become loose, and then tweezers are used to separate the components from the circuit board. The downside or disadvantage of this method is that it can be very difficult when small and individual components are taken into consideration. This is because heat that melts the solder on parts that are closely situated can dislodge components that are not meant to be desoldered.
To acquire the objectives for this report, a list of client and user requirements was obtained. Here shows each requirement strategically listed. The client and user requirements was then analyzed to highlight the main characteristic traits of the desired machine, thus producing portability, efficiency, user-friendly, cost, and low environmental impact. The main attributes were then used to develop a metrics table which provides a ranking system for future design concepts to assess how well the design achieves the requirements defined by the user and client. Here shows each ranked from not good to very good. Design specifications act as a framework to guide in the creating of conceptual designs that would achieve the requirements prescribed by the client and user. The following points outlines the design specifications that is integral to the creation of a circuit board decomposition machine. Cost. The machine should cost between $50,000 to manufacture. Environment. The machine should produce no waste. Safety. The machine noise level should not exceed 60 decibels and it should be properly ventilated. Function. The machine should take less than 90 seconds to remove the components from one circuit board. The solder should be removed via heating processes. Size. The machine should be compact, meaning that it could be loaded on Class 4 vehicles. Materials. The The material should be obtained locally and contain no less than 50% recyclable material. For the pairwise comparison, each main attribute was ranked to show their importance towards creating a comprehensive design. With this, it was observed that efficiency and user-friendly had the highest ranking at 28%. Second is low environmental impact and cost at 20%. And a third is portability at 4%.
Hello, my name is Ryan Cummings, and I'll be taking over for this part of the presentation where I'll be discussing the various conceptual design that is being put forward by our design team. In order for us as a design team to come up with conceptual designs that meet the desired client and user requirements outlined in the previous slides, we must first look at the main components of a system, which is shown here using a functional decomposition chart. The chart shown here outlines the main or important sections of a design that must be fulfilled in order to meet the desired requirements. In order to construct a machine of this nature, the following are the required inputs that the machine needs. For example, the used/damaged PC laptop motherboards, which are destined to be recycled, electrical energy, mechanical energy, and human energy, which is then passed on to the processes, where the main process is to decompose the old/used PC motherboard. And then the output of the system would be separated electronic components, clean circuit board, heat energy produced from the various processes, and also sound and noise energy as a result of those processes. The functional decomposition chart can be further broken down into a flow chart to show the various sub-processes that make up the desired machine. As you can see here, the energy input, usually inputted by using electrical energy, is converted to mechanical energy, which is used to drive conveyor belts and shaft, etc. Also, the operator inputs the mechanical energy needed, which is usually to place the circuit board components onto an assembly. The solder is then removed, which is controlled using a signal, which is used to operate the temperature. This process produces an output of heat energy. Also, electrical energy is needed at this point in order to generate the heat. The next process is the component removal. Then the output of the system would be the through-hole connected components. As a result, this produces sound energy, and also an output from the system would be the remaining surface components and the circuit board, from which the through-hole connected circuits have been removed from, and also a visual interface for the operator. To aid in the design process, a morphological chart was developed. This is a table based on function analysis and is used as a guide to generate design for the sub-processes outlined in the leftmost column. So for this chart, the sub-process needed for the recycling machine is outlined in this column, in the leftmost column, and then across the rows represents the different ways in which each design or each process can be done. Now we move on to conceptual design 1. This table represents the breakaway from the morphological chart shown earlier, highlighting the various design aspects that would be implemented in conceptual design 1. For example, loading would be done using a conveyor system, heating will be done using hot air via convective processes, and solder removal will be done using a drip tray. Now we would look at conceptual design too. This table also shows a breakaway from the morphological chart, highlighting all the design concepts used in design 2. For example, a conveyor belt is also used for the loading, hot air is also used for heating, and solder removal is done using a braided wick. Before a design is selected, it must first be judged, using the metric rating system established earlier. Each design will ranked and their score is then recorded and tabulated in the table shown. In this table, the leftmost column represents the main attributes which were ascertained from the client and user requirements. The table shows the ranking of each design concept with respect to each category. The raw scores were then taken and analyzed using a selection matrix, where the relative weightings of the main attributes from the pairwise comparison chart shown previously is multiplied by the raw score to produce the weighted score. This is done for each design for a particular design attribute. For example, in the first row, under relative weighting from the pairwise chart, efficiency was found to have a relative weighting of 28%. Design 1 had a raw score of 2 in the efficiency section, which then produces a relative weighting of 0.56. This is repeated for each design and each category or each main attribute. The total is added up and then the design with the highest score is selected, as this design best meets the client and user requirements. And now for the chosen design. Now we will look at conceptual design tree. This table also shows the morphological chart breakaway, highlighting all the major design elements used in the creation of conceptual design tree. For this design, loading is done via a manual process, heating is done during convective hot air, and solder removal is done via the drip tray, etc. For this design, the enclosed machine is loaded from the higher side of the drum through a hatch door using manual labor. The boards are deposited onto the inner mesh of the rotating drum. From this image, we can properly see the internals of the machine. The green arrow shows the directional placement of the circuit board into the machine as they are placed in batches into or onto the inner wire mesh. Heating for this machine is done via a convective process. Hot air is fed into a barrel using two insulated tubing systems and dispersed throughout the enclosure over which the circuit board's solder is heated while in the process of component removal. This method of heating is monitored using a digital PID, which is proportional integral and derivative temperature controller, built into the shaft to help increase efficiency of the separation and the process to remove the components at constant temperature. The PID temperature controller would be located at the center of the barrel to avoid inaccuracy of the instrument gauging the temperature. This image shows the location of all the internal components of this design. After the solder have been removed, the components would separate from the board and slip through the bigger wire mesh into the smaller wire mesh as the circuit board slowly rolled down at a 15-degree angle towards the lower end of the barrel. These components are removed due to the vibration and turning effect of the wire meshing with respect to the shaft of the barrel. The components would eventually exit the outer meshing and fall into the component section of the bin. This image shows the various release points for the solder, component, and PCB boards. Each part of the PCB board is unloaded as the board moves along the 15-degree angle of the barrel to the other end. The solder components, then the board which makes up the PCB, is unloaded respectively through the bottom of the barrel into the section bin tray. When the bin is full, it is manually removed from the bottom base, emptied, and then placed back into position for a next batch of circuit boards. From the selection matrix, it was seen that design concept 3 was best suited for meeting all the design requirements laid out by the user. Some of the reasons were due to its small compact design, its ease of use, it's easy to manufacture, no technical skill is required for its operation, its scalability, etc. Now that we have settled on a design that best achieves the user and client requirements, we must first model and analyze the chosen design, test and evaluate the chosen design, refine and optimize the chosen design, and complete the details as constructed in the model. Secondly, we must move on to design communication, which entails the description of the design process, design calculation, drawings, and design details, also the fabrication specifications. Thank you for watching.